Welcome back. Today, we're diving into the world of Allen-Bradley PLCs, a dominant force in industrial automation, brought to you by Rockwell Automation. Whether you're new to the field or need a refresher, understanding their controller families and software is crucial. From their early days in motor control, Allen-Bradley became pioneers in programmable logic controllers, even coining the term PLC. They didn't invent the first one, but their early models like the PLC-2, PLC-5, and the influential SLC-500 cemented their legacy. Now, Rockwell Automation is a global leader, especially strong in North America. Their connected enterprise vision drives integration from the plant floor up, with modern controllers acting as key hubs. You'll often hear PLC and PAC, Programmable Automation Controller. Modern Allen-Bradley units like ControlLogix are PACs, handling logic, motion, process, and safety in one platform. Rockwell offers controllers for every scale. Let's look at the main families relevant today, bridging legacy and modern systems. First, the legacy systems, often programmed with RSLogix 500, the SLC 500, introduced in '91, was a modular, affordable step-up from older systems. It uses file-based addressing like N7:0 or B3:0/1. While aging, the Ethernet-equipped SLC5/05 is still found in many plants. The MicroLogix family, starting in '94, targeted smaller, cost-effective applications. Think standalone machines. These are typically brick-style controllers with built-in I/O, expandable to the side. They also use RSLogix 500 and file-based addressing. The MicroLogix 1400, with its built-in Ethernet, remains a popular workhorse. Remember, this is distinct from the newer Micro 800 family using CCW software. Now, the modern Logix platform, programmed with Studio 5000 Logix Designer. These are PACs. The CompactLogix family bridges the gap. It's powerful, uses tag-based addressing, descriptive names like motor speed instead of cryptic addresses, and is great for complex machines or smaller integrated systems. Newer series like the 5380 offer high performance and integrated motion. At the top sits the ControlLogix family. These are modular, chassis-based PACs for the largest, most demanding applications. Entire production lines, complex process control, high-speed motion. They offer the highest performance, scalability, redundancy options, and use Studio 5000 with tag-based addressing. Choosing between these families often comes down to hardware capabilities. Processing power. ControlLogix, especially the L8 series, is the fastest, ideal for high-speed tasks. CompactLogix 5380/5480 offers excellent performance for complex machines. MicroLogix and SLC 500 are suitable for simpler, less time-critical applications. Memory. ControlLogix has the most memory for large, complex programs. CompactLogix offers substantial memory for mid-range needs. MicroLogix and SLC have less, suited for smaller applications. I/Os and scalability. ControlLogix handles thousands of I/O points, both local and distributed, with features like online module changes. CompactLogix handles hundreds, good for machines or system areas. MicroLogix has limited local expansion. SLC 500 is moderate, supporting some remote I/O. Size and cost. MicroLogix is the most compact and cost-effective. SLC is chassis-based, but older. CompactLogix offers modularity in a smaller footprint than ControlLogix, sitting in the mid-range cost. ControlLogix is the largest and most expensive, reflecting its premium capabilities. Application scale. Match the controller to the job. MicroLogix for small standalone machines. SLC for legacy systems. CompactLogix for complex machines and mid-size systems. ControlLogix for large-scale, plant-wide, or critical high-performance applications. The software environment is just as important as the hardware. There are two main suites: RSLogix 500, used for SLC 500, and MicroLogix. It features a simpler, older interface focused primarily on ladder logic. Its strength is file-based addressing, requiring you to manage memory locations like N7:0. Licensing is simpler and generally less expensive. Studio 5000 Logix Designer, the modern environment for CompactLogix and ControlLogix. It's an integrated suite with a more complex but powerful interface. Its biggest advantage is tag-based addressing, using meaningful names. It supports multiple programming languages: ladder diagram (LD), D, function block diagram (FBD), structured text (ST), and sequential function chart (SFC), letting you use the best language for the task. Studio 5000 promotes code reuse through user-defined types (UDTs), custom data structures, and add-on instructions (AOIs), reusable code blocks. This speeds up development and standardizes code. A critical point with Studio 5000 is versioning. The software version must match the controller's firmware revision exactly. You might need multiple Studio 5000 versions installed. Licensing is tiered and more complex, with higher costs, especially for advanced features or controller support. Inside Studio 5000, projects are organized hierarchically. Tasks determine when code runs, continuously, periodically, at fixed intervals, crucial for timing, or triggered by events. Programs organize logic within tasks. Routines contain the actual code, ladder, structured text, etc., with subroutines called as needed. The tag database is central. You define tags with names, data types, bool, dint, real, al, and scope, controller-wide or program local. UDTs allow creating complex data structures, like grouping all data for a motor. AOIs let you encapsulate logic, like a standard motor starter block for easy reuse. Communication setup relies on RSLinx Classic, older, or FactoryTalk Links, newer, to configure drivers like Ethernet, IP, or USB, and browse for controllers to connect to for downloading, uploading, or going online to monitor logic in real time. Firmware, the embedded software on the hardware, needs management. Updates provide bug fixes, security patches, and new features, but require careful planning due to the strict Studio 5000 version dependency. Use Rockwell's product compatibility and Download Center PCDC website to find firmware, check compatibility, and read release notes. The ControlFlash Plus tool is used to download firmware to devices, often over Ethernet IP or USB. It can update multiple devices and helps manage revisions. The update process involves backing up your program, ensuring compatibility, establishing a stable connection, putting the PLC in program mode, running ControlFlash Plus, and never interrupting power during the flash. Afterward, restore the program and test thoroughly. Modern automation relies on networks. Ethernet IP is the standard for Allen-Bradley's Logix platform. It uses standard Ethernet hardware, but applies the Common Industrial Protocol, CIP, for robust control data exchange. It supports high speeds and resilient topologies like device-level ring DLR. CIP is the key. It's the common language used across Ethernet IP, ControlNet older deterministic, and DeviceNet sensor actuator bus. This allows seamless integration. Logix controllers easily integrate with panel view HMIs using FactoryTalk View or Studio 5000 View Designer. PowerFlex drives, kinetic servos, safety devices, GuardLogix, Safety I/O, SCADA systems, and numerous third-party devices, often directly configured within the Studio 5000 project triggers. From relay replacers to powerful PACs driving the connected enterprise, Allen-Bradley offers a wide range of solutions. So which Allen-Bradley PLC are you using or planning to learn next? Drop a comment in comment section. If you found this video helpful, hit the like button and subscribe for more control system content. Your feedback shapes our next videos. See you in the next one.